Hi guys, this is Mr. Robeson. Today we're looking at how to do the inverse, or the opposite of what we were doing last time with the normal probability. So last time we found the probability of being like between or below or above a certain like x value on a normal distribution. Now we're given the probability and we want to work backwards to find the x values. All right, so how do we do this? Well, it's built into your calculator. It's in the same menu as normal CDF. So like if we do second, and then we go to that vars button again for the distribution menu. It's the third one on that menu, and it says invNorm. It stands for inverse normal. All right, so it's the inverse of the normal CDF that we were just doing. And once you do it, it brings you to this menu. The menu might be a little bit different depending on what calculator version you're using, but it asks for the area, then it asks for the mean, and it asks for standard deviation. It leaves 0 and 1 in there to start, but we're probably going to change those. All right, so it's second, vars, and then number 3, area, mean, standard deviation is what we know, and then we just have to press enter a few times until it gives us an answer. All right, so back to our example here with the golden retrievers. So we already said the mean weight of a golden retriever is 70 pounds with a standard deviation of 6 pounds, and weights are normally distributed. What weight is the 70th percentile of the dog weights? All right, so 70th percentile means we're greater than 70% of the data. So for all of these problems, if I were you, I would draw just a little normal curve. It doesn't have to be perfect. Mine never are. All right, so the mean would be right here in the middle with 70. No, it's strange. This 70, not that 70. Maybe I should have used a different number here. Oops. All right, so we're greater than, we want to find the x value that's greater than 70%. So in other words, in here would be 70%. All right, or 0.70 if we're talking about area, 70%. And we want to find this x value. That's what we're trying to find here. All right, if it ever says percentile, it means it's 70% is below that, where that x value would be. And the way we find that is we go to inverse norm. And when it asks for area, the area below where this line is that we just drew is this 70%. It's the 0.70. So we always put in the area to the left. So it's always the area to the left of the data value, that side. All right, the mean we're going to put in is this 70 up here, and the standard deviation we've got is the 6. And we're just going to put this in the calculator and see what value it gives us. So let's see, there's our calculator. So second vars, down to the third option, inverse norm, we get 0.70 for our area. Our mean is going to be 70 also. And our standard deviation is going to be 6. And we paste it, and then we press enter, and we get 73.146. All right, and that's our answer. So this value must have been at 73.146. So if we go up by, looks like 3.146. If we go up by 3.146 from the 70, then that'll give us 70% below that data. All right, more questions like this. What weight must a dog weigh above to be in the top 10% of weights? All right, so if we draw the curve, and I do suggest doing that for every problem, just draw this little curve. It doesn't have to be perfect. And let's see, we've got 70 as our mean in the middle. And we want to be in the top 10%. Well, the top 10% is going to be somewhere over here. All right, we want to know that x, and this is 10%. All right, so if we go to inverse norm, because we're trying to find an x value, not a probability, so that means we're doing the inverse of what we were doing before, the area is not going to be 10%. Because remember, the area is always to the left. So to the left of this line, if this is 10%, this is 90%. So this is 0.90. or 0.9. All right, our mean is still going to be the 70. Our standard deviation is still going to be the 6. Hopefully it'll be saved in there already for us. We could actually just press second enter and just type over it if we want, but I'm going to do second vars number 3 just to remind you where it is. And now we've got 0.90, 90% below the data. And we get 77.68, so 77.7 about. All right, so as long as our dog weighs above 77.7 pounds, it would be in the top 10% of all dog weights, or of all golden retriever dog weights. What weight must dogs be below to be in the bottom 20%? All All right, well, we'll draw another curve. All right, our mean here is in the middle of 70, and we want to be in the bottom 20%. So that means down here somewhere we have 20% or 0.20 as a decimal. All right, and then we want to find this x, this weight that we would have to be below to be in the bottom 20%. So again, we're using inverse norm. The area here is the 0.20 because that is to the left of that line. So here's the line, and we want to the left of it. This is to the left of it. All right, our mean is still the 70, and our standard deviation is still the 6, and we're just typing that in. All right, so we can, shortcut here is just press second enter, and then go back and just change this number. Just type right over it to 0.20. All right, 64.95. I don't really care how many decimal places, one decimal place at least. You can use 2 or 3, whatever you want, but at least one decimal place. All right, another example. So more practice here. Suppose the mean score of ACT math is 21. So here's our mean with a standard deviation of 4 points. There's our standard deviation, and that scores are roughly normally distributed. What score, I forgot I changed this problem, would be the top 10% of scores? And this is going to be scores. And this is going to be scores. All right, so top 10% is, let's say our mean here is 21, and we want to be in the top 10%. So that means this is 10% up here. All right, so that means if we want to find this x value, we're trying to find an x value. That means we're using inverse norm. The area is the area to the left of this. So to the left of it is that side. If we have 10% on this side, that means we have 90% on that side. So 0.90. Our mean here is 21. Our standard deviation here is 4. So we're going to go to our calculator and type that in. So second vars number 3. We've got 90% already. 21 is our new mean. 4 is our new standard deviation. And press enter. And we get 26.12. Or 26.1, it's probably plenty. All right, so if we score above a 26.1, according to this data, we'd be in the top 10% of scores. All right, what scores would be in the bottom 15%? All right, so we draw our curve just so we know what's going on, so we can find what's on the left. Bottom 15, so that's going to be down here, and this in here is going to be 15%, so 0.15. And that is the section that is to the left already, so we're good there. So if we're trying to find an x value, we use inverse norm. The area to the left is the 0.15. The mean is 21. The standard deviation is 4. And we go to our calculator, and we're going to really just have to change that 90 to a 0.15. 16.85. All right, so if we're below 16.85, we'd be in the bottom 15%. All right, and the last one here, what would be the middle 50%? All right, so this is where it gets tricky, and it really is 2 separate problems. So here's our mean here, 21. We want this middle 50%. So that means we want 50% to be in the middle here, and we want to find these 2 different x values, x1 and x2, I'll call them. All right, so if 50% is in the middle, if we subtract, that means we have 50% left over to split evenly between this bottom part and this top part. So if we split it evenly, divided by 2, that leaves us with 25% in each of these sections. So this section has 25%, and this section has 25%. So 25, 50, 25. All right, basically it's quartiles, if you remember that from box plots. All right, so to find x1, what's to the left of x1 is just this 25%. So we would do inverse norm. The area here would be 0.25. The mean is going to be 21. The standard deviation is still going to be 4. So let's find that one. So second entry, I'm just going to change this 15 to a 25. And 18.3. And that was x1. So that was the bottom one. All right, now to find the top one, we want to know what's to the left of this guy. Well, this 50 and the 25, so that would be 75% is to the left of him. So we get 0.75 there, The mean is still the 21. The standard deviation is still the 4. So this is giving us x2. So now we just need to change that 25 to a 75. So second enter brings it right back. And we just type over this 75. 23 point, it looks like that'll round up to 7. And that's x2. So those are the two scores that we would be between. So what scores would be the middle 50%? Anything between those two numbers, 18.3 and 23.7. All right, and we do the same thing if we had like the middle 60%. We would do 1 minus the 60, would give us 40. And then we'd split the 40 between the two sides. It'd be 20 and 20. And one of them we would use the 20. The other one we would do the 20 plus the 60 in the middle. All right, there is 1 or 2 of them like that on the homework, so be ready for it. All right, so that's it for this. So check out the homework for this, and don't forget to submit your notes.